Okay, the first problem we're going to do is we're going to find the roots of z cubed minus 3 plus j4 equals 0. So the first thing we want to do is we want to isolate z by itself. So I'm going to go ahead and start that by doing z cubed equals 3 minus j4. So I added the 3 and I subtracted the j4. Now what we need to do is we need to turn this in rectangular form to exponential form. And to do that, what we need to say is z cubed equals, and now I need the square root of 3 squared plus 4 squared e to the power of j theta. And to find theta, it's equal to the arctan of negative 4 divided by 3. So the first thing I'm going to do, I'm going to go ahead and plug this into my calculator. So I'm going to get the 9 plus 16 is 25. The square root of 25 is 5. So I'm going to have z cubed equals 5e to the j. And now I want to keep this in radians, so make sure you're in radians. The next thing we need to realize is arctangent is only good in, I'm going to go to blue, in these two quadrants. Otherwise, we have to convert it back to, if we want this quadrant here, it'll end up giving us this quadrant, so we need to add pi. And then same thing here. If we want this quadrant, it's going to give us this quadrant, so we need to add pi. But that's not the case here. For the case here, we are in 3, 1, 2, 3, and then 1, 2, 3, 4. We're in the fourth quadrant, so it works. So we're going to do arctangent. So I'm going to put in my calculator. So arctangent of negative 4 divided by 3. So I need to round that. And then I get negative 0.9273, roughly. So my equation will be z cubed equals 5e to the j negative 0.9273. Now I need to get z by itself. So I need to just z alone. So to do that, I take the cube root of both sides. So this cancels out. And so I get z equals the cube root of 5 and the cube root of e to the negative j 0.9273. Let me sum that up. Okay, now we have our equation, and I recommend you put this equation on your cheat sheet for your cheat sheet. So it's theta I equals this sign here. I'll explain what everything means here in a second. All right, so the first thing we need to do is we need to figure out what this trident thing is. And what that is equal to your theta here. So equals negative 0.9273. Now we need to figure out what n is and L is. Well, n, I'm going to put n in red. N is equal to whatever value is here. So 3. L is equal to, we're going to start from 0 and go 0, 1, 2, and then this is 3 values the same as n. So you can think of that as n minus 1 from 0 to n minus 1. That's the best way of looking at it. So this is 0 through n minus 1. So now we can go ahead and we can plug this into each one. So the first thing I'm going to do is I'm going to find my theta 0. which is equal to negative 0.9273 plus 2 pi L, and L is this value right here, so 0, all divided by 3. Well, this goes away, and all I'm left with is negative 0.9273 divided by 3, and just plug that in your calculator, and we get theta 0 equals negative 0.3091. Okay, I'm going to box this because we're going to need this in a bit. So I'm just going to box this for now. Now I need theta 1, which is equal to negative 0.9273 plus 2 pi times 1 divided by 3. And all you're going to do is just going to plug this in your calculator. So you're going to do negative 0.9273 plus 2 pi, and all that is divided by 3, and I get 1.7853. Now also remember, we're in radians, so make sure that this value here, whatever you got, is in radians. So this is our next number. Now we go to our final number. So I have theta 2 equals negative 0.9273 plus 2 pi times 2, all divided by 3. So I'm going to go ahead and put that in my calculator. Negative 0.9273 plus 4 pi divided by 3 is 3.87969. Well, this value is greater than our principal angle. So if you remember, our principal angle is, if I can do this properly, we're only concerned with pi or negative pi to pi. This value would be just right around here. So to do that, we need to subtract 2 pi to get this angle here. So I'm going to do the same thing. I'm just going to do minus 2 pi to get it within a principal angle. So I get theta 2 equals negative 2.4035. Now I can put all these together. So I'm going to start off. So I'm going to say Z0 equals the cube root of 5. This number will always stay the same. This number here, your amplitude, it's always going to stay the same. So don't worry about that. So now I'm going to plug in e to the j. And what number do we get for 0? Was negative 0.3091. Negative 0.3091. Make sure you can read that perfectly. Okay. Now I'm going to have z1 equals the cube root of 5, e to the j. Now let's go ahead. What do we get for 1? 1.7853. 1.7853, and then we have z2 equals the cube root 5 e to the j, and negative 2.4035, and then these would be your actual answer. So just to recap, the very first thing we do is we isolate z on its own. I hope you see my cursor. We isolate z by putting everything in rectangle on the right side. We put everything from rectangular into exponential. Then what we do is we start figuring out what our angle is. Remember, make sure you're in radians. Let me put that. Radians. Make sure that is in radians. It's not going to work if you're in degrees. Realize what your n is. Your n is whatever value is up here. And then your L is just 0 through n minus 1. And all you do is you just plug these values into our equation, which I wrote right up here. If you need to, please put that on your cheat sheet. And that is how you complete this type of problem.